see some text, string of text on the screen. So now back to the flawed program. This S1 equals S2, what is it really doing then if we now understand what's going on underneath the hood? What's it comparing? S1 and S2. So let's finish this picture. I typed in goodbye before. So what do I need for goodbye? Well, I need another chunk of memory that's going to have G-O-O by \0. And now let me just break it up pictorially with lines. So now I'm going to get back, this is, I said before, maybe address 4, 5, 6, 7. So what's going in S2? 4, 5, 6, 7. Again, numbers don't matter, but that a number is there matters. So what am I comparing? You know, I'm kind of comparing I am comparing two distinct addresses. So even if I typed in hello here, they're going to end up at different locations in memory. The computer is not smart enough to realize, oh, you typed in hello twice. I'm going to optimize this and just reuse that same memory. No, getString is going to use a different chunk of memory. It's going to thus be at a different place in RAM. So what are you comparing? Two addresses. And so, yep, they are wrong. Those are not correct. So let's see this, actually. So S1 equals S2. Let's actually print this out. So let me just make some temporary space here. Printf, and I'm going to say S1 is %s, comma, S1, semicolon. And actually, let me put a new line in there. And now I'm going to also say S2 is %s, paste in S2. And let me I'll leave that in there. So S1 is something, S2 is something. Let's go ahead and compile this again. So let me go down to my terminal window. Let me go ahead and do make compare 1. Compiled OK. Let me run compare. I'm going to type in hello. I'm going to type in hello again, just as I started with. Enter. OK. So at least they look the same, but I'm saying I typed different things. So let's look underneath the hood. S1 is not %s. Let's actually print it as what it really is, a pointer, %p. So this is going to show me the address, hopefully. So let's scroll down here. And now let me go ahead and recompile. Let me rerun it. Hello, hello, and wow. So the numbers are not as simplistic as 1, 2, 3, 4. They're much bigger. They're 32 bits. But now you see that they're so close, right? But they're actually a few bytes off. They're 10 bytes off from each other. Notice the 3 for S1 and then the 4 for the next. So there's a bit of an offset there. And that's just because getString has put one of the strings over here, the other one over here. And they're pretty close, but they're not the same. So how might we go about solving this? What do we have to do in order to compare two strings? Sorry? A to I. OK, so if we used A to I, ASCII to integer, we could convert a string to a number. But the problem here is that HELLO is not a number. So this is a little distinct from Caesar, where you might have typed in 13. And even though that is a string, you want it as a number. Hello is a string. It's not a number. So not quite. What could we do? Oh, yes. So there is, in fact, a string compare function. Very, very good. Googling? Yeah, OK, very good. So there's a string compare function. All right, so let's actually borrow that. So I actually don't remember how to use it. So let me go to cs50.net/resources. Let me go to the little cheat sheet up here, the C reference. This has something to do with strings. So I'm going to click down here in the bottom left corner, standard C string and character functions. String compare. OK, these are all kind of abbreviated, as is the convention. String CMP, that sounds like string compare. All right, so it looks like in string.h, there's a function called strcomp, strcmp, that stands for string comparison. It apparently takes in two arguments, string 1 and string 2. They are indeed strings, because again, char star is synonymous with string. There is a new keyword here, but you can probably guess what this means. Const. So it means constant. So C actually has this mechanism, and you might have seen this in man pages before, where you can say, just to be extra paranoid that you don't screw up the user's inputs, you can say, I'm going to receive str1 and str2, but I'm specifying they are constant. I am not going to take any liberties with these, like a function like swap might, and move them around. I'm going to promise to whoever's calling me that I will take in your parameters as constant, even though you're handing them to me by pointer. as suggested by the star. So this is just a convention that's good practice, so no need to be too distracted by it. So here's the summary. The function strcomp compares string 1 and string 2 and then returns. So this is interesting. It doesn't return a Boolean. It actually returns one of 3 values. So string comparison will return 0 if what's the case? If str1 is equal to str2. And in this context of the documentation, it means literally equal, like the words are the same in a human sense. But it will also, just to help you out, return less than 0. It probably returns -1, but the programmer didn't even want to make that commitment. He or she just said, I will commit to returning a negative number to you. So if it returns less than 0, that means str1 is less than str2. And if the function returns greater than 0, that means str1 is greater than string 2. What does it mean for a string, though, do you think, to be less than or greater than? What's that? Oh, not a bad thought. So not correct, but it could be the sum of the values, because these are just ASCII characters. But that's not it. It's even more simplistic than that. What's that? Could be the length, but even that's not on point here. Alphabetical. That's what it's doing. Right? So this is actually very compelling. If you want a function that compares 2 strings alphabetically, you actually have it in strcomp already. It doesn't just tell you equal or not equal. It tells you which one comes alphabetically first, less than, or which one comes alphabetically later, greater than. So you can compare 2 strings. So now already we have a function that could apparently allow us to implement something like binary search, which again we've done on the board here with Sean, that doesn't just search for numbers. Now we could actually search for words like Mike Smith in a phone book implemented in a computer program. So let's try this. Apparently to use this, I have to include string.h, and then I have to know about these return values. So let's go back here. All right, so rather than do equals, I'm going to go ahead and get rid of my temporary pointer printing. And now I'm going to say not this. I want to compare. So I want to call strcomp of s1, comma s2 if it what? Equals 0, right? And again, that's just from the documentation. If it equals 0, that means they're the same. So you know what? I don't care about alphabetical less than or greater than here. I'm going to keep it simple and just say yes or no, same or different. So if strcompare s1, s2 equals 0, hopefully this will fix my bug. So let me scroll down here. Let me go. Oh, error? Ah, good. So good point. This is going to break when I try to compile it. What error am I about to see? Yeah, so something undeclared, right? So let's do a quick recompile, make. Ooh, implicit declaration of function strcomp. What does that mean? Well, that just means that I forgot to declare it. I don't need to declare it. I need to include whatever file it's actually declared in. So let's go ahead and type string.h there. Scroll back down. Let me recompile with make. That seems to be good. Let's compare. Let's say hello. Make sure I didn't break the only part that was working. OK, different things. That's good. Hello. Hello. Finally, it's actually working. So there is this magical function, strcompare. But you don't need these magical functions, right? Printf is useful. It's kind of non-obvious to me how I would actually make stuff appear on a computer monitor. But comparing 2 strings, if you understand what's going on underneath the hood, should actually be pretty tenable. So let's actually do this. I'm going to say, you are not allowed to use strcompare. So for instance, string.h, we accidentally deleted it, along with string.c. So just conceptually, how can we take in 2 inputs, like string 1 and string 2, and compare them and say yes or no, same or different? Yeah? Oh, perfect. So we could just compare each character. And what do we do as we compare? What's that? So iterate through. And I start comparing the left end against the left end, and then here, and then here, and then here. And at what point can I make a decision or just quit altogether? So if you see null at the end, or if it's different in any location. So let's try this. Let me go ahead and say, OK, for int I gets 0, I is, let's say, less than the string length of s1, I++. Let me go in here now and say, OK, so if, how do I express if the leftmost character of either is different? Do something. If, think back to Caesar. If s1, oh, so we should. So if I could just say if s1 bracket I does not equal s2 bracket I, so just compare their ith locations, what can I do? Well, I can say you typed different things, semicolon, and then I can quit, right? So let's say return 1, because something bad happened. That's an error. But not quite, right? I just made a bug. Right, so we need the brackets. Otherwise, only one of those lines will actually get executed. So let me go back in here. Let me do this. And now, again, I feel like I got some issues still. But I'm going to claim that if I at least get way down here, is it pretty safe to assume that 1, 2, 3, 4? So this is kind of my catch-all. If I get all the way through the loop and I don't actually return prematurely and yell at the user for having typed different things, I can claim you typed the same thing. Right? All right, why not? What's flawed here? I still need what at the top? So I actually do need string.h, but why this time? Damn it. OK, so I'll give you that back. Right? So I don't really feel like implementing string length just yet, though we could. Right? How do you implement string length, frankly? Yeah, just start at the beginning and then count, 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 count. So we'll come back to that or maybe assign it on a quiz or something. But it's pretty easy to implement string length if all you have to do is take in a string, start iterating over each of its characters, and the moment you hit \0, stop counting. You're done. You found the end of the string. All right, so we'll give you str length, but not string compare. Right? So I'll take away Google from you. How about that? So now we can't string compare with the function, but we can do it this way. But I actually think this is flawed for a couple of reasons still. Yeah? Yeah. Exactly. Let's see what happens. Maybe nothing, maybe something. Let's see what happens if I save it as is. I go back here and I recompile. And I type in S1 that's pretty long, but an S2 that's pretty short. Right? Because how many times am I going to iterate according to my for loop at the moment? The length of S1. So it feels like there's bad opportunity here. So let's run this. So say something like, I am a very long string hello. OK, S2. OK, it worked. Not broken. Correct. Correctness 5. Why is it actually flawed? Can we still break this? I just need to stall for a moment here. OK. What's that? Oh, OK. So cat and cat. Oh, yeah, you know, I'm kind of an idiot. Right? So what are we doing? I'm comparing a really long string against a really short string. But guess where they differ? At the first location. Right? So not a problem. I'm actually catching that at the beginning. So let's Control C. Let's start this over. And let's say caterpillar. Enter. Did I spell that right? Really? Hang on. I'm giving us. There we go. I had to take Google back. OK, so. Damn it, I forgot what I copy pasted. Caterpillar. All right. Come on, that is not a word I've had to type very often in life. All right. So here we go. Caterpillar. OK, cat. Switch them around. Cat. Caterpillar. That was only a surprise to me.